Welcome to our deep dive, everyone. Ready to unearth some serious knowledge about dinosaurs?
Always ready for a dino deep dive.
Well, we've got a fantastic presentation here, absolutely packed with dino facts. Think of it as a cheat sheet to everything awesome about dinosaurs.
That's good to me.
So, let's get right into it. First things first, what exactly were dinosaurs?
Okay.
I mean, we've all seen the movies, the giant skeletons in museums, but what actually makes a dinosaur a dinosaur?
That's a question that often causes confusion. This presentation jumps right into it. It defines dinosaurs as reptiles that roamed Earth millions of years ago. They belong to this group called Dinosauria.
Okay, so they're reptiles. Got it. But I mean, there were tons of other reptiles back then, too.
Right.
What sets dinosaurs apart?
Exactly. And the presentation makes it super clear what sets them apart: their upright stance. Dinosaurs had limbs positioned directly beneath their bodies.
Hmm. Okay, so like a dog standing on four legs versus a lizard sprawling out on its belly.
Precisely. And you know that seemingly small difference had massive implications for their movement and evolution.
Oh, I see. So that upright posture allowed them to move more efficiently, and that's what led to the incredible diversity in size and shape we see in dinosaurs.
Right on. This presentation says that this upright posture really paved the way for everything from the massive, long-necked herbivores to the fearsome predators we all know and love.
Okay, that makes sense. But weren't there other ancient reptiles that also had an upright stance? I'm thinking of those sail-backed dimetrodons.
Ah, you're sharp to catch that. Yeah, the presentation actually addresses that. It talks about a more specific classification called dinosauromorphs.
Dinosauromorphs. That's a mouthful.
It is. And this group includes dinosaurs and their close relatives. So yeah, they all shared that upright posture. But true dinosaurs had other distinctions, like specific features in their hip and ankle structures that set them apart.
So it's all in the bones. Well, I guess that makes sense since we're talking about creatures that lived millions of years ago.
Absolutely. The fossil record is our key to unraveling the dinosaur story. And this presentation takes us on a journey through time, starting with the Mesozoic era.
The Mesozoic era, often called the Age of Dinosaurs, right?
You got it. It spanned from about 250 to 66 million years ago. And it's divided into three periods: Triassic, Jurassic, and Cretaceous. Think of it like chapters in the dinosaur story.
Okay, I like that, chapters. So let's start with chapter 1, the Triassic period. What was the world like back then?
This presentation paints a pretty dramatic picture of the Triassic. It was a harsh world, hot, dry, with vast deserts and active volcanoes.
Oof, not exactly a tropical paradise, huh?
No, not really. But even in these tough conditions, dinosaurs emerged. The presentation highlights the Coelophysis, a small, agile predator from this period.
Coelophysis, I'm not familiar with that one.
It was one of the earliest dinosaurs we know about, like a pioneer of the dinosaur world navigating this challenging landscape.
Wow, it's amazing to think about those early dinosaurs making their way in such a harsh environment. But hold on, the Triassic wasn't only about dinosaurs, was it?
You're right. It was a world teeming with other creatures too. Reptiles, early mammals. This presentation even mentions marine and flying reptiles like pterosaurs.
Pterosaurs, those are the flying reptiles that often get lumped in with dinosaurs, but this presentation actually makes a point of separating them, right?
Exactly. Even though they coexisted with dinosaurs and were the first vertebrates to achieve powered flight, they weren't actually dinosaurs themselves. They were on a separate evolutionary branch.
Fascinating. So pterosaurs were like the cool cousins of dinosaurs, sharing the skies, but not quite the same family.
You got it. It's a distinction that a lot of people miss.
I can see why. It seems like every detail we uncover adds another layer of complexity to the dinosaur story. It's incredible.
It really is. And speaking of adding layers, let's move on to the Jurassic period.
Okay. The Jurassic. This is when things start to get really interesting. The presentation mentions a dramatic climate shift. Warmer, wetter, lots of lush forests emerging.
Yeah, the Jurassic was a time of incredible growth and diversification for dinosaurs, the perfect environment for them to thrive.
Ah, the Jurassic. This is the period that pops into my head when I think of dinosaurs. Giant creatures roaming through dense jungles. Is that image accurate?
You're pretty close. This presentation emphasizes that the Jurassic was a time of abundance for dinosaurs. The warm, wet climate led to this explosion in plant life, which in turn fueled the evolution of gigantic herbivores like Brachiosaurus.
Ah, Brachiosaurus,
Oh,
with
yeah.
its long neck reaching high into the tree. So it was a product of this Jurassic boom.
Exactly. The presentation says that the abundance of food in the Jurassic allowed them to reach sizes that would have been impossible back in the Triassic.
Makes sense. I mean, you got to eat to grow big. It's incredible how changes in the environment directly impacted dinosaur evolution.
And that connection between environment and evolution continued into the Cretaceous period. This era saw even more diverse climates and environments,
Mhm.
plus the emergence of flowering plants.
Okay, so more diversity, more challenges, more opportunities for dinosaurs to evolve and adapt.
You got it. And the Cretaceous period is when some of the most iconic dinosaurs roamed the Earth.
Okay, so we're talking about Tyrannosaurus rex and Triceratops, right?
Bingo. The presentation points to the Cretaceous as the peak of dinosaur diversity.
Okay, I'm getting a sense of the when yearn. But what about the where? Did dinosaurs only live in certain parts of the world?
That's where things get really interesting. Remember, during the Mesozoic era, the continents as we know them today were all joined together in one giant supercontinent called Pangaea.
Oh yeah, Pangaea. I remember learning about that in school.
So dinosaurs weren't confined to one specific location. They roamed across this massive supercontinent. And as Pangaea gradually drifted apart, dinosaurs spread across the globe.
So they were a global phenomenon. That's wild. This presentation is seriously blowing my mind. I mean, how do we even know all this? How do scientists piece together this incredible story from millions of years ago?
Well, that's a great question. And that leads us to the amazing world of paleontology. Scientists are constantly digging up clues to the past.
Okay, I'm ready for another deep dive. Let's unearth some of those paleontological secrets. Okay, so paleontology. It sounds kind of like detective work, right?
You know, it really is. And this presentation does a great job of explaining just how paleontologists uncover the secrets of the dinosaur world. Their main tool, fossils.
Fossils. I mean, that makes sense. Those preserved remains of ancient organisms like
Awesome.
dinosaur bones, right?
Exactly. And they're like pieces of a giant puzzle scattered across time. A dinosaur bone here, a footprint there. Paleontologists use these fossil clues to reconstruct dinosaur skeletons, to understand their anatomy, even to infer their behavior.
Wait, really? So, like, you can tell how a dinosaur moved just from its fossilized bones?
Yeah, and this presentation gives a really cool example. Fossilized footprints. They can actually reveal details about a dinosaur's movement and speed.
You're kidding. Footprints can tell us how fast a dinosaur could run. That's amazing.
Yeah, isn't that cool? By analyzing the spacing and depth of the footprints, paleontologists can estimate the speed and gait of the dinosaur that made them. It's like having a prehistoric speedometer.
Wow. So it's not just about bones, right? Every fossil, no matter how small, can tell us something.
You got it. And the presentation makes it clear that we're not just talking bones and footprints. There are fossilized eggs, teeth, even fossilized plant matter. All these things give us clues about the ecosystems dinosaurs inhabited.
So, like a detective, paleontologists use all these clues to build a picture of the past. It's incredible.
It really is. And speaking of detective work, there's this big mystery that has captivated scientists for centuries.
Oh, yeah. The extinction of the dinosaurs. What happened to these creatures that ruled the Earth for millions of years? It's like the ultimate cold case.
Right. And the presentation lays out the leading theory, a massive asteroid impact, about 66 million years ago.
Okay, I've heard about this. So a giant asteroid slams into Earth, causing all kinds of chaos and ultimately wiping out the dinosaurs.
That's the theory. It's believed to have triggered widespread devastation, massive fires, tsunamis, and a global dust cloud that blocked out the sun.
Oh, wow. So the planet gets plunged into darkness. That sounds pretty apocalyptic.
It does. And the presentation points to a specific impact crater, Chicxulub, in the Yucatan Peninsula of Mexico.
Chicxulub. Okay, I've heard of that.
Its size and age align perfectly with the timing of the dinosaur extinction. It's a pretty strong piece of evidence supporting this theory.
It's mind-blowing to think about, one single event could have such a huge impact on the whole planet, wiping out entire species. It really makes you think about our own planet's vulnerability.
It really does. And the presentation actually suggests that the asteroid impact might not have been the only factor.
What do you mean?
Well, it points to other contributing factors like intense volcanic activity and gradual climate change, things that were already putting stress on ecosystems.
Oh, I see. So it was like a perfect storm of events that led to their demise.
That's the picture the presentation paints. The asteroid might have been the final blow, but the dinosaurs were already facing a changing world.
Okay, I'm starting to get a clearer picture of this extinction event. And it's a good reminder that extinction is rarely caused by one single event, right? It's usually a complex interplay of factors.
Absolutely.
Okay, so we've covered a lot of ground. What made dinosaurs unique? Their incredible reign across different eras, the extinction event, and the fascinating science of paleontology. But there's one burning question I still have.
I'm all ears.
We've talked about dinosaurs as a group, but we haven't really gotten into the specifics of their lives. What did they eat? Were they social creatures? How did they interact with their environment?
Excellent questions. Let's see what this presentation can tell us about the daily lives of these prehistoric giants.
I'm ready to dive deeper.
Let's do it. And a good place to start might be with their diets. What was on the dinosaur menu?
Okay, so what did dinosaurs eat? Did they all have the same eating habits?
Well, no, not at all. This presentation makes it clear that dinosaurs had a wide variety of diets, just like animals today.
That makes sense. So some were herbivores, some were carnivores.
Exactly. And their diets were closely tied to their anatomy. For example, the presentation highlights the sharp serrated teeth of carnivores, like Tyrannosaurus rex.
Oh, yeah. T-Rex, the king of the dinosaurs, definitely a carnivore. But what about the plant eaters? Did they all just munch on leaves?
Not necessarily. The presentation points out that different herbivores had specialized adaptations for eating different types of plants. Like, take the Brachiosaurus with its long neck.
Yeah, Brachiosaurus, reaching high into the treetops to browse on leaves, right?
Right. While others, like the duck-billed hadrosaurs, had rows of grinding teeth for chewing tough vegetation.
So cool. It's like evolution equipped dinosaurs with specific tools to help them thrive in their environments.
Exactly. And it wasn't just about teeth. The presentation even suggests that some herbivores, like Stegosaurus, might have swallowed stone.
Swallowed stones. Why would they do that?
It's thought that the stones help to grind up plant material in their stomachs, similar to how birds use grit today.
Wow. Dinosaurs with sharp teeth for hunting, specialized teeth for chewing plants, even swallowing rocks to help them digest. It's like a masterclass in adaptation.
I like that. A masterclass in adaptation. And while we're talking about adaptation, the presentation also touches on something pretty interesting. Dinosaur social behavior.
Oh, okay. So were dinosaurs loners or did they hang out in groups?
Well, the presentation suggests that both lifestyles existed. Paleontologists look for clues in the fossil record to try and figure out the social structure of different species.
What kind of clues?
For example, if you find multiple dinosaur skeletons close together, especially if they're of different ages, that could be a pretty good indication that they lived in herds or family groups.
So, like, finding a bunch of fossilized Triceratops skeletons all together would suggest they were a herd? That makes sense?
Exactly. And this presentation points to another piece of evidence. Trackways.
Trackways. Those fossilized footprints.
Yeah. Especially when you find them in large groups showing parallel movement, it suggests that dinosaurs were moving together.
Like a prehistoric family road trip. All those footprints captured in stone. Amazing.
And speaking of bringing dinosaurs to life, the presentation also touches on a topic that fuels our imaginations. Their size.
Ah, yes. The giants of the prehistoric world. I'm ready to be amazed. Were all dinosaurs massive creatures?
Well, that's where things get interesting. While we often picture dinosaurs as towering giants, they actually came in a wide range of sizes.
Oh, really? I guess I haven't thought about that.
The presentation mentions Compsognathus.
Compsognathus.
This little guy was no bigger than a chicken. On the other end of the spectrum, you have Argentinosaurus, believed to be one of the largest land animals to have ever existed.
Wow, a dinosaur the size of a chicken. That's wild. So it wasn't all about being big and scary.
Right. And the presentation highlights how dinosaur size was often related to their lifestyle and ecological niche.
Makes sense. I mean, a smaller dinosaur might have been quicker and more agile.
Right. They could dart through the undergrowth, maybe even climb trees, while the larger ones were likely slower moving, relying on their size for defense or to reach food sources that others couldn't.
Okay, so size mattered, but it wasn't everything. It's amazing to see how all these pieces fit together, their anatomy, diet, social behavior, size, all shaped by evolution.
You got it. It's this complex interplay of factors that makes studying dinosaurs so fascinating. And speaking of fascinating, remember we were talking about how dinosaurs are often depicted as slow and lumbering?
Oh, yeah. Is that true? Were all dinosaurs slowpokes?
Well, that's a question the presentation tackles head on.
Okay, I'm ready to bust some myths. What's the real story? So were dinosaurs really the slowpokes we often imagine them to be?
Not necessarily. The presentation makes it clear that while some dinosaurs, especially the really massive ones, might have moved at a more deliberate pace, Plenty of others were incredibly agile and swift.
Okay, so not all dinosaurs were built for speed, but some were definitely quick on their feet. The presentation must have some examples, right?
Oh, it does. It specifically mentions the velociraptor.
Velociraptor. Now, those are some cool dinosaurs.
Yeah, they're pretty iconic.
Yeah.
A small, feathered predator, often portrayed in movies as a lightning-fast hunter.
And based on fossil evidence, that depiction isn't too far off, right?
You got it. Their lightweight build, long legs, and sharp claws definitely made them formidable predators. The presentation even suggests that some dinosaurs might have reached speeds comparable to modern-day cheetahs.
Whoa. A dinosaur as fast as a cheetah. That's incredible. It really makes you think about how dynamic these creatures were.
It really does. It's amazing what paleontology can reveal about the past, bringing these creatures to life in our imaginations.
Speaking of seeing things in a new light, remember those pterosaurs we were talking about? The
Mhm.
flying reptiles that weren't actually dinosaurs?
Yeah, those fascinating creatures. What about them?
Well, the presentation makes a clear distinction between pterosaurs and dinosaurs, but it also dives into their unique anatomy, especially their wings.
Oh, that's right. Their wings were formed by a membrane of skin stretched between an elongated fourth finger and their ankles.
Okay, so like a giant hand with a super long pinky finger, all covered in skin.
That's a pretty good way to picture it. And the presentation emphasizes how different this is from the wings of birds or bats.
Right. Birds and bats have wings supported by multiple fingers.
Exactly. So pterosaurs, they had their own unique evolutionary path for flight, distinct from both dinosaurs and other flying vertebrates.
It's amazing how evolution comes up with so many different ways to solve the same problem. So even though they shared the skies with dinosaurs, pterosaurs were in a league of their own.
Absolutely. And speaking of evolution, this presentation does something really thought-provoking. It encourages us to consider what might have happened if that asteroid hadn't wiped out the dinosaurs.
Whoa, that's a mind-blowing question. What if the asteroid had missed Earth completely? Would dinosaurs still be around today?
It's a question that sparks so much imagination. And honestly, the presentation doesn't offer a definite answer. But it does suggest that the dinosaurs' extinction opened up ecological niches for mammals to diversify and evolve, which ultimately led to us.
Wow. So if the dinosaurs hadn't disappeared, mammals might not have had the chance to thrive. The world could be a completely different place.
It's a fascinating thought experiment. It really highlights how interconnected life on Earth is and how even a single event, like an asteroid impact, can change the course of evolution.
It's incredible to think about, and it makes you realize how much we still don't know about the past and how it continues to shape our present.
Exactly. And I think that's a great takeaway from this deep dive. We've learned so much about dinosaurs, their origins, their evolution, their extinction, and the amazing science that allows us to piece together their story.
It's been a wild ride through millions of years, and it's definitely left me with a sense of awe and wonder about the world around us. Thanks for taking this deep dive with me.
It's been my pleasure. And to all our listeners out there, keep exploring, keep questioning, and never stop digging deeper into the mysteries that surround us.